Hello everyone. In this video, we are going to discuss the second type of numericals which are based upon the hydrographs. So let's start. So the first problem says that the following is a set of observed data for successive 15 minutes period out of the total 105 minutes of the storm in a particular catchment. So in the first column, the duration in minutes that is given, and corresponding to that duration, the rainfall is given. That means when we looked at the first 15 minutes, then the rainfall intensity was 2 centimeter per hour. Then in the next 15, it remained the same as 2 centimeter per hour. Then it increased up to 8 centimeter per hour and so on. Now, if the value of the phi index, that is the abstraction losses or the infiltration loss, if that is 3 centimeter per hour, we have to estimate the net runoff, the total rainfall, and the value of W index. So for the given data, what we will do, the plot between the duration and the rainfall intensity, that is known as the hydrograph, in which on the x-axis we represent the duration and on the y-axis we represent the rainfall intensity, and that too in centimeter per hour. So for the 15 minutes, then for 30 minutes, then for 45 minutes, then 60, then 75, then 90, then 105, then 120. Okay, starting with the 0. So for the first 0 to 15 minutes, the rainfall intensity was 2 centimeter per hour. So this will be the rainfall intensity at 2. Then again for the next 15 minutes, it remained the same as 2 centimeter per hour. Then for the next 15 minutes, it jumped up to the 8 centimeter per hour. So let's say this is corresponding to 8. So this line will be representing the 8 centimeter per hour. This is corresponding to 8. This is 4. This is 6. Then for the next 15 minutes, the data is suggesting that it is 7.0. So the next value is 7.0 in between these two, and that is up to 60 minutes. Then 1.25 and 1.25, that is maintained, and then 4.5 for the last 15 minutes. It is 4.5. So this is 4.5, this is 7.0, this is 8. Both of these are 1.25 and it is 2.0. Now what we are going to utilize that is given the phi index value. So the phi index, which is the infiltration loss, that is given as 3 centimeter per hour. So we will mark at 3, that is 3 centimeter per hour, and corresponding to it we will draw a line which is parallel to the x-axis, which is representing the phi index, that is at 3 centimeter per hour. Now this value is indicating that if any rainfall is below 3 centimeter per hour, that will be completely infiltrated. So this portion of the rainfall will be completely infiltrated. So whatever is remaining, that I am highlighting with the yellow color, that is available only as the runoff. So first of all, we will calculate the parameters, that is the total rainfall that has occurred. So the total rainfall will be For the first 15 minutes, the intensity was in centimeter per hour and the duration was in minutes. So for the first 15 minutes, converting it into hours, that is 60, has to be divided by 60 into the intensity was 2. Then again for the next one, it is 15 by 60 into 2 plus again the duration is 15 minutes, 15 into 60 into 8, then 15 by 60 again into 7 plus 15 by 60 into 1.25 plus 15 by 60 into 1.25 again, and last value is 50 by 60 into 4.5. So the total rainfall that we will get from this calculation, that will be equal to 6.5 centimeter. That is the value of the total rainfall that we are getting in this duration for the given values of the rainfall intensity for the different 15 minutes durations. Now the net runoff that we have to calculate, that will be corresponding to these three yellow shaded portions. So this is contributing towards the net runoff. So to calculate the net runoff, we have to carry out certain calculations. So the values which are below the phi index, that will not be contributing whatsoever in the runoff. But the values which are greater than the phi index, they will be contributing, but only the portion which is above 3 centimeter per hour. So the 8 centimeter per hour minus 3, that is the first ordinate that we will be getting. So the net runoff will be 8 minus 3 centimeter per hour into the duration was for 15 minutes, converting it into the hour. The next value is 7 minus 3 into 15 by 60 plus, then the next value is 4.5 minus 3 into 15 by 60. Now multiplying these with the values, so this will be 5 by 4, that is 1.25 plus it will be 1 plus it will be 1.5 divided by 4, so that is 0.375. So from here, if we add up these values, then we will get the result as 2.625 centimeter of the net runoff. Now if we go back to the problem, so we were to calculate the net runoff that we have estimated, the total runoff that has also been estimated. Now we have to calculate the W index. Now this W index, for this we have already read the particular formulation, and that is equal to the total infiltration divided by the total duration. So this will be total infiltration divided by the total duration. That is the value of the W index. So to calculate this total infiltration, therefore the total infiltration, that will be equal to the total rainfall that we have received minus the net runoff, because only that portion will be infiltrated. So the total rainfall that we have received in this duration, that is 6.5, minus the net runoff is 2.625. So this value that we are getting is equal to 3.875 centimeter. That is the total infiltration. Therefore, the W index that we want to calculate will be equal to the 3.875 centimeter divided by the total duration of the storm is 105 minutes. Now from this calculation, the answer will be in centimeter per minute. So we will convert it into the hours. So convert that, we have to divide it by 60, and now the units will be in hours. So after the calculation, the W index that we will be getting, that is equal to 2.214, and the units will be in centimeter per hour. So this is the one result, this is the another result, and the total rainfall that we have calculated here. So these are the three results which were required in the first problem. Moving on to the next one. So the problem says that in a catchment, the average rainfall for a storm at two successive 6 hours interval was 3 centimeter and 6 centimeter respectively. The abstraction losses, that means the phi index, that was estimated to be 0.2 centimeter per hour. For the same catchment, the calculated data for the 6-hour unit hydrograph that is available and is given below. We have to find the direct runoff hydrograph due to the storm. Now we know the data corresponding to the phi index, that is 0.2 centimeter per hour. Now the first rainfall occurred for the 6 hour, that is from 0 to 6. Then next one occurred from 6 to 12. In the first rainfall, the total rainfall that we have received, that is equal to the, for the first one the rainfall was 3 centimeter. Therefore the excess rainfall that will be equal to the total rainfall, that is 3 centimeter minus 0.2 centimeter per hour, that is the phi index, into it lasted for 6 hours. So from here the value we will be getting as 1.8 centimeter, that is the effective rainfall depth for the first rainfall. Correspondingly for the second one, the total rainfall was of 6 centimeter. Therefore the excess rainfall was 6 centimeter minus 0.2 into 6 because of the duration of the storm. From here the result that we are getting is 4.8 centimeter. This is the effective rainfall depth in this second case. Now we are having the ordinates of the unit hydrograph. So first column will be corresponding to the time, and the second one will be the ordinates of the 6-hour unit hydrograph, starting from the 0, then 6, 12, 18, 24, 30, 36, 42, 48, 54, then 60. So ordinates are for the unit hydrograph, that is 0, 10, 25, 40, then 100, 150, then again 100, then 75, 25, 15 and 0. So corresponding to the first DRH, that is the direct runoff hydrograph, for the first one we have to multiply the ordinates of the unit hydrograph by the effective rainfall depth for the first storm, and that was 1.8 centimeter. So 0, 10 into 1.8, that is 18, then 25 into 1.8, that is 45, then 72, then 180, then 270, then again 180, then 135, then 45, 27 and 0. Now the next storm that has occurred, that is the direct runoff hydrograph for the second one, and that will be the unit hydrograph into the effective rainfall depth of the second storm. But what you have to keep in mind that the second rainfall that has started after the first rainfall has occurred. So during the first hours there will be no runoff because of the second rainfall. So for the first 6 hours there was no rainfall in this second case. So therefore the first value will be at 6 hours. Then corresponding to 10 we will be getting 10 into 4.8, that is 48, because we are multiplying here by 4.8. So 48, then 25 into 48, 25 into 4.8, that is 120. Similarly 192, then 480, then 720, then again 480, then 360, 120, 72 and 0. So the direct runoff hydrograph of the storm, that will be the combination of these two, that is 0, then 18, then 45 plus 48, that is 93, then 192, then this will be 372, then 270 plus 480, that is 750, then 900, then 615, then 405, 147, 72 and 0. These are the ordinates of the direct runoff hydrograph of the storm. Now that completes the entire range of the problems which can be discussed in the unit hydrograph and the S-curve hydrograph. Now in the next video we will start the new unit, that is the groundwater. Thank you.